Yo, this is Mr. O. Yo, this is Mr. O. And today we're going to learn about proving congruent triangles using ASA, angle side angle, AAS, angle side, and hypotenuse leg or HL. All right, let's go ahead now. Congruent triangles proof, ASA, is an angle side angle congruence theorem. This is when two angles and the included side is the one between the two angles, are congruent to two angles and an included side of another triangle. Then the two triangles are congruent. So let's look at this figure on the left. I have here triangle ABC and triangle DF. If I say that angle A is congruent to D, if I say that angle B is congruent to E, and the included side, which is the one between them, are congruent also, then we can say that the two triangles here are congruent using angle side angle congruency theorem. So if A is angle A is congruent to angle D, side AB is congruent to side DE, and angle B is congruent to angle E, then we can say the two triangles are congruent. So we can say triangle ABC is congruent to triangle DEF. Okay, and that's how you identify if the two triangles are congruent using ASA. Let's apply it using this problem here. Given that segment SQ bisect angle RQT, so SQ is a bisector of the angle RQT. So therefore, this angle here and that angle there are equal. So we know already that SQ bisect RQT, so that will give me a given there, right? And also, if that's a bisector, I know that RQS and TQS are equal because which is already stated in number 2. For what reason? That's definition of angle bisector. Since the bisector cuts an angle into equal parts, we can say that two angles are congruent, the RQS and the TQS. But hold on, there's an additional statement here that SQ is a bisector of RST. So this will be congruent. So if they're congruent, I know that RSQ, which is this one here, and TSQ, which is right here, are congruent, and same for same reason, definition of angle bisector. So we're trying to prove here that the QRS, the triangle number 1, and the QTS, triangle number 2, are congruent. We can tell already from the given that the two angles are congruent. So we need one more parts of this these two triangles to be congruent in order for us to jump in that they are congruent to the both triangles. So we have used already the given. Let's look at the picture. Just looking at the picture, let me erase this one here. We know now that these two here are equal. We know that these two here are equal also. One more. Where is that? This side here. They share the same side. So therefore, QS is congruent with QS. And for what reason is that? Reflexive property of equality. It is equal to itself. So now we have an angle, a side, and an angle, and here an angle and side and angle. We can say that the triangle QRS and triangle QTS are congruent using ASA congruency theorem. Okay, there you have it. If the problem was not this, and I ask you to prove angle R is congruent to angle T, you have to do all this step in 1 through 5 here. Number 6 here will be angle R will be congruent to angle T using CPCTC. What CPCT stands for is, again, this is the corresponding parts of congruent triangles. Sorry, corresponding parts of congruent triangles are congruent. Meaning, say, after you have proven that the two triangles are congruent, then the remaining corresponding parts of the triangle are congruent. I know that angle R and T was not mentioned on the given nor on the statements, but since we already proved in number 5 that the two triangles are congruent, then the remaining parts will be congruent also. Same thing with TS is congruent with RS, and so on and so forth. Okay, let's go to the next congruence theorem, which is the AAS. If two angles and a non-included side of one triangle are congruent to the other two angles and an non-included side to another triangle, then the two triangles are congruent using angle-angle side congruency theorem. So here, if I say that angle A is congruent to angle D, and then angle B is congruent to angle E, and then the side non-included means say it's not between them. Like here, side BC is congruent to side EF. Then we can say that two triangles ABC is congruent to DEF. Okay, non-included means say the side opposite the angle, means a side opposite to the angle. So the opposite to this angle is this one here. So it could be also opposite to angle B, which will be right here. So either way is fine. Okay, all right. Let's write the example here. YZ bisect WYX. And YWZ is congruent to YXZ. That's a given. And you're trying to prove that the triangle WYZ is congruent to XYZ. So you're trying to prove that triangle 1 is congruent to triangle 2. Okay? But we know, just planning it purposes to overview, that YZ bisect angle WYX. WYX. This is the bisector. If that's the bisector, I know that this angle is congruent to that one. It says here that angle YWZ is congruent to YXZ. So these two here are equal. So I already have proven the two angles are congruent. So now, what is the next one? Do they share the same side? Yes. If they share the same side, most likely you're going to prove that YZ is congruent to YZ using reflexive property of equality. And that's the overview. Let's go ahead now, shoot it in our two-column proof. So for the beginning, so we say here that YZ bisects angle WYX. And that's the given. Okay. The next one there, we're going to write angle YWZ is congruent to angle YXZ. That's also a given. Now let's apply the given. Since we know that YZ is a bisector of the angle WXZ, it makes these two angles here equal. So I can say that angle WYZ is congruent to angle XYZ using the definition of, why were they equal again? Because it said they're cut by a bisector. So it's angle bisector. Forgive me, guys. Next, I have here an angle. I have here an angle. I have here an angle. Angles. I need one more, and I know that YZ, they share the same side. So segment YZ is congruent to the YZ there. So I have say that they are reflexive. Now we can say that we have an angle, and a side there. So therefore, we can say the triangle WYZ is congruent to triangle XYZ using the angle side congruency theorem. Take note, I wrote the AAS here as a guide. You can swap them around. What really matters is the image here, that you have an angle here and an angle here and a side here, angle and angle side here. The way you write here doesn't justify what theorem you're going to use proving the two triangles. Okay. Next, right triangle congruency proof, the HL. If the hypotenuse and the leg of one right triangle is congruent to the hypotenuse and a leg of another right triangle, then the two triangles are congruent. Remember, guys, that the two right triangles are equal already at a certain angle, which is where the 90 is. Because wherever the 90 is, they're always going to be equal, okay? Because they're both right angle. Okay, that's part of the theorem or right angle theorem. Now, the hypotenuse is the one opposite to the 90-degree angle, which is this one here and that one. And the leg could be any of the side of the right triangle. So if, on this case here, assuming this is a right triangle, if BC is congruent to EF, and any leg, let's say BA is congruent to ED, then we can say that's enough for us to say that the triangle ABC is congruent to triangle DEF. The hypotenuse is a side opposite to the right angle, and the leg is a side adjacent to the right angle. So it means adjacent could be this side here or that side. Okay. Let's try this one here. Triangle LMP. Where's LMP? LMP and MNP. So triangle 1 and 2 are both right triangles. Okay. We're going to prove that the two triangles here are congruent. So ML is congruent to MN. Where's ML? ML is right here and MN is right there. Those are opposite to your box, to your 90-degree angle. That means the hypotenuse have proven to be congruent. And then I know they're sharing the same side again. If they're sharing same side, that will be a reflexive. MP is congruent to MP. Okay. And that will be enough for us to prove the two triangles are congruent. Okay. So let's go ahead now. Triangle LMP and MNP are right triangles. That is given. By the way, if you notice, I worked the problem by analyzing and having a good overview of the given and the figure. After that one, that's when I jump into the two-column proof. So I make a plan first before doing the work right away. Okay, given. Okay, and ML segment ML can go to MN. That's part of the given. That ML and MN are your hypotenuse, and you know that MPs can go to MP because they are reflexive, and that's your leg. So that's enough for you to say the triangles LMP and NMP are congruent using HL congruency. And there you have it. And as always, kaboom.